In this video, I'm going to go over the last three problems. I'm going to set them up for you for our solubility curves worksheet. They're a little bit harder, so I wanted to include them. So to make a little bit more room, I'm going to just fold them up like this, so that way we can do them on paper down here, because you're not really going to have a lot of room. So for 15, here's what we're going to do. It says 0.85 moles of Ki are dissolved in 100 grams of water at 10C. Is the solution saturated, unsaturated, or supersaturated? Now, normally you wouldn't be able to do a problem like this because if you look at Table G says grams of solute dissolved in 100 grams of water, and then the temperature. So unless you have the grams they dissolved and in how much water they dissolved it in, it makes it hard to use Table G. But they told you that you have 0.85 moles of Ki. So if we use the mole formula, we can take our 0.85 moles of Ki, figure out the GFM, I'll let you do that, solve for grams, and then that's how many grams is dissolved in the 100 grams of water at 10C. So then we would just go to that amount of grams, go to 10C, and then find the point, and then is it on, above, or below the Ki line, which is all the way up here, and then that's your answer. So I'm not going to do it for you, but I did give you a setup. For 16 says at what temperature, notice there's two stars. It's a little harder, but it's really not harder. At what temperature will an 11 molar solution of NaCl be saturated? Well, let's think about this. Normally, again, we would need grams, but there's a molarity formula. We have moles over liters, right? We know that it's 11 molar. We also know that Table G says this is in 100 grams of water, and it actually goes a little further and tells you that a gram of water is the same as a milliliter of water. The reason that is because the density of water is 1, so 1 gram ends up being 1 milliliter because of its density, but that's only for water, and that's only because it's 1. But here's the good thing. That means that if I know that Table G is in 100 grams of water, well, that's 100 milliliters of water, which if I use King Henry is 0.1 liters of water. So I put 0.1 liters in there, and again, I got that off of Table G. Then I solve for moles. Now I'll know moles of NaNO3. Once I get my answer, I plug it in for moles, I can figure out my GFM, I solve for grams. Once you know the grams of NaNO3, you could then answer the question, because now they're going to give you some amount of grams of NaNO3, and they're going to say, at what temperature would that amount of grams of NaNO3 be saturated? So you'd essentially go to however many gram number you get, you go over to the NaNO3 line, you hit the line, you drop the line down, and then that's the saturation temperature. But in order to get that gram amount, you've got to solve for moles first, then use the mole formula to solve for grams. Then you actually answer the question. So that's 16. And then 17. What temperature is the molarity of 100 grams of HCl? What is the temperature of a 100 gram HCl solution that has a saturation point of 45 degrees C? Wait, I read that wrong. What is the molarity of a 100 gram HCl solution? All right, so this 17, it's the same problem as 16, but reversed. So what you would do is you'd go to 45C and you'd go to HCl and you find out how many grams can dissolve. So 45C, you go up to HCl, you pretty much hit this line, and you get 60 grams. So I know I have 60 grams of HCl that can dissolve at 45C. They want to know the molarity. Well, guess what? You use your 60 grams, you figure out your HCl, which is 36, I believe. Let me double check. I forget if chlorine is 35 or Chlorine rounded is 35. So 36 is your GFM. Solve for moles. You then know how many moles it is. We know that table G is in 100 grams of water, which is really 0.1 liters. I did that up here. And then you could figure out your molarity. So these are not difficult problems. They're just using the mole and molarity formula in addition to table G. That definitely can be done.